We're already on the air. Okay, we're live from Woodland Park. Okay, what we're going to do is we're going to put this equation in standard form. Now, just by looking at it, okay, we're in the section on circles, so it's going to come out to be a circle. But if you didn't know that and it just said, hey, put this conic in standard form, this is how you start out. Okay, no matter what this long thing looks like, you're always going to start out the same way. We're going to kind of put all our x things together and all our y things together. And that's how we're going to separate it up here. So you'll notice you have an x squared minus 2x there. And then you've got kind of like the little complete the square part there. Are you seeing that?
Yeah.
And then you should have a y squared plus 6y. Do you see that?
Uh-huh.
And you're going to have that little complete the square there thingy. And then over there on the very last side, you're going to see equals negative 6. Are you with me on that? What they're doing is they're putting this x squared and this negative 2x together. Then they're putting the y squared and negative 6, or y squared and 6y together here. They're going ahead and subtracting the negative 6 from both sides to get you this over here.
So it's kind of like ZPP.
Not zero product property yet, but what we're doing is we're completing the square twice.
Okay.
Once for the y's and once for the x's.
Okay.
And the reason we do that is to get it, if it were a parabola, you only have to complete the square once because you only have one squared term. In circles, when you're looking at the major equation, it's x minus h quantity square plus y minus k quantity square equals 0. The whole idea behind completing a square is being able to write it as a perfect square. So we have to be able to write it for a perfect square in the h's, or the x's, and a perfect square for the y's. And that's what we're doing here.
Okay.
So let's go ahead and write this one down. This is x squared here. If I split minus 2x up, I'm going to end up with a minus x and a minus x. Let's figure out our sides here. This is x, this is x. What's this going to be here?
Minus 1.
Minus 1, minus 1. What's negative 1 times negative 1?
1.
1. So what I'm going to have to do here is I'm going to have to add 1, aren't I? Yes? And so what if I added 1 over here, what do I have to add over here?
Subtract 1.
No, 1. Add
Oh,
1
yeah,
because I'm
just
doing
add
it
1.
completely to the other side of the equation. Sorry, if it were on the same side, the total would be 0. Okay, let's do this one here. We're going to go ahead and complete the square here on this side.
Okay.
And this is y squared here. Half of 6y would be 3y, so 3y goes here and here. This is y, this is y. How long is this little piece here?
3.
And this one here is 3.
3.
So what am I going to need here?
9.
9. So I'm going to add 9. If I add 9 to one side, what do I have to do to the other side?
Add 9.
Add 9. Perfect. Okay, so what we're going to do now is rewrite these as perfect squares, which you probably see below. So this one is going to look like x minus 1 quantity square plus, even though I left out my plus up here, y plus 3 quantity squared equals, and I can go ahead and combine everything here. It would look like negative 6 and 1 would be negative 5 plus 9 would be 4. Yes?
Yep.
Dudes, I have an equation for a circle right here. Okay, so what's my center of this one going to be?
1, negative 3.
1, negative 3. Perfect. What's my radius going to be?
2.
2. Perfect. Okay? So that's what you're doing. Whenever you've got this big long form here, you want to get all your x squares and x's together, all your y squares, do your completing the squares, write them as perfect squares, boom, you're done. Okay? So let's go ahead and do our next example. You can go ahead and write out that big and long enchilada. And this is going to be a little different because there's a number in the front. 4x squared plus 4y squared plus 20x minus 16y plus 37 equals 0. And again, they've just basically set it up into two separate things. First thing I'm going to do is write all my x's together. 4x squared plus 20x, and I'm just going to kind of leave it right here for now. Are you okay with that? Over on this side, I've got 4y squared minus 16y. I'm going to go ahead and subtract 37 from both sides. So what am I going to end up with over here?
Negative 37.
Negative 37. Perfect. Now remember, whenever you're completing the square, if you look at this original formula up here, this x does not have a coefficient, does it?
No.
I mean, it's got a 1, right? So I can't have this 4 in there when I'm completing the square. So I'm going to have to factor that out. So before I start filling my little box, I want to factor that out. So that's going to look like 4 times x squared plus 5x. And I'm going to go ahead and give me some room in a parenthesis there. Are
Okay.
you seeing that?
Uh-huh.
And I'm going to go ahead, and while I'm looking at the x's, let's go ahead and finish completing that square just because it's easy to do one at a time. I'm going to bring this x squared down. Now my middle term is a 5x. What's half of 5x? Do it the nice way. You could say 2 1/2,
Mm-hmm.
but that's not the nice way.
3 halves.
5 halves. 5 halves.
Oh, yeah.
5 halves. Remember, because using fractions makes it easier, especially when you have to start squaring. So what's this little length going to be right here? 5 halves. 5 halves. What's going to go down here?
25 over 4.
25 fourths. That's why using the fraction is easier. Right?
Uh-huh.
Okay. So what am I actually adding here? Plus 25 over 4.
Adding 25.
I'm really adding 25, aren't I?
Mm-hmm.
Because 4 times 25 over 4 is 25. So let's go ahead and put it over here. It looks like negative 37 plus 25. And we don't know what we're doing for the y's yet. So far, so good?
Mm-hmm.
Okay. You want to go ahead and write this as a perfect square down here a little bit? It's going to look like 4 times x plus 5 halves quantity square. And we just get this from our completing the square. And then we're going to move over to our y component. Good to go?
Mm-hmm.
All right, so on the y component,
You factor out the 4.
I have to factor out the 4 as well. So 4 parenthesis, y squared minus 4y. Let's leave this open a little bit. If we draw our picture, this is y squared. What's half of the negative 4y?
Negative 2y.
So negative 2y here and here. So this is y, this is y. What is this here?
Negative 2.
Negative 2 and negative 2. What's going to go down here?
4.
Perfect. So I'm going to add 4 here. Am I really adding 4? What am I really adding?
16.
16, because 4 times 4 is 16. So let's go ahead and put 16 on the other side. The reason we added 16 to this side, so we have to add 16 to the other side. Remember, sometimes we were subtracting,
Mm-hmm.
but that's when we did it all on the same side because you have to total equaling 0.
Okay.
All right? So let's rewrite this as a perfect square. 4 parenthesis y minus what? 2 quantity squared. And we can total up all this. Let's see, negative 37 plus 25 gives
Equals
me
Oh, that equals.
negative 12 plus 16 gives me a positive 4. That's what you were saying. You were giving me the
Yeah.
final answer. Okay, perfect. Well, I'm not done yet because you'll notice in this equation up here, what's the coefficient in front of the x minus h quantity squared?
1.
A 1, right? So I don't have that here. What do I have in front here?
A
A
4.
4.
So
I have
you
a
divide
4 and a 4. I'm
both
going to divide
sides by 4.
in both the whole thing by 4. 4 over here and 4 over there. And I'm going to erase a little bit of this so we can see what we're doing. Sorry about that. And we'll rewrite it as x plus 5 halves quantity square plus y minus 2 quantity square equals 1. Because this 4, okay, this 4 here, these both have a 4 and this has a 4, so all those will cancel. And then 4 over 4 is 1. So that's going to be your final answer there.
What do you do if if the coefficients aren't all the same and you can't divide?
Then you're not going to have a circle.
What is that then?
It's going to be an ellipse.
Oh, okay.
Okay? Now the deal is, on those other ones you'll see there's fractions involved.
Uh-huh.
Okay? Circles always work out real nice like this. Okay? I don't know why I have 0 there. What should it be?
R squared.
R squared. Okay. Go ahead and tell me the center of this one real quick.
It would be
-5
negative 5
comma
halves 2.
Negative 5 halves 2. And what would my radius be?
1.
1.
1. Okay, perfect. So you've given me everything about the circle that I need to know on this one. Okay? And that's as much notes as we're going to take on circles. So we're good on that one.